Today we're going to look at section 5.8, applications of trig functions. So we're going to continue to solve right triangles, and we're also going to look at problems involving bearings. Okay, so trig was first developed to measure heights and distances that were inconvenient or impossible to measure directly. In solving application problems, begin by making a sketch involving a right triangle that illustrates the problem's conditions. Then find the required distance or height with your knowledge of solving right triangles. So essentially, we're going to take what we did yesterday, but we are going to have to sketch our own picture based off of the situation and then find whatever it's asking for. So it says, from a point on level ground 80 feet from the base of the Eiffel Tower, the angle of elevation is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So we're always going to want to start off with a picture of a right triangle. Sorry, it's not writing for whatever reason. Let's try it again. Here we go. Okay, so picture of a right triangle. They want us to find the height of the Eiffel Tower. So hopefully we're all okay with understanding that the height is going to have to be this vertical leg right here. It says from a point on level ground 80 feet from the base of the Eiffel Tower. So anytime they're talking about the base, they're talking about the bottom. So we're talking about starting at a point over here, and we're 80 feet from the base. So we are talking about 80 being that distance on the bottom. So then finally, the other key vocab word is angle of elevation. There are several different angles that we could be looking at, but your angle of elevation is always when you are looking straight ahead, and when you elevate your eyes, you start looking up. So from that point on the ground, we are, level with that 80. So then when you look up, that tells you that the angle of elevation is this angle here on the ground. So that's the 85.4 degrees. So once again, you want to make sure that your calculator is in degree mode. We don't want it in radians, so make sure that it's in degree mode. But from there, now that we have this sketch, we're going to think about SOHCAHTOA. And we're going to use the correct information to find what x is. Notice that the directions are asking us to round to the nearest foot. So based off of the angle, we are wanting to find the opposite, and we are given the adjacent side. So opposite and adjacent means that we have to think about tangent. So the tangent of 85.4 degrees is going to equal x over 80. So to get x by itself, we just have to get rid of that denominator. We're going to multiply both sides by 80. That gives you the x that you want. And then go ahead, put that into your calculator. We want to round to the nearest foot. And so in the calculator and rounding, we should get 994 feet as our final answer. Let's do another one. It says a guy wire is 13.8 yards long and is attached from the ground to a pole 6.7 yards above the ground. Find the angle to the nearest tenth of a degree that the wire makes with the ground. So once again, we always want to start by sketching a picture of the situation. We want a right triangle. So a wire is attached from the ground to the pole above the ground. So think about the fact that the vertical side is going to be the pole. The wire is going to be what is then slanted. So from the top of the pole down to the bottom, that is going to be 13.8 yards. It says that we have a pole 6.7 yards above the ground. So that is going to represent the height of that pole. We want to find the angle to the nearest tenth of a degree that the wire makes with the ground. So the wire is hitting the ground down here. We want to figure out what that angle is. I'm going to call it x. So we want to think about SOHCAHTOA. Notice that in this, x is what I want to find. 6.7 is opposite, and because 13.8 is across from the right angle, that's the hypotenuse. So opposite and hypotenuse, we're thinking sine. So we want the sine of x to equal 6.7 divided by 13.8. Remember, when you're trying to find the measure of an angle, we want to use our calculator as the inverse sine. So second sine, and then we want to do 6.7 divided by 13.8. Once again, remember, we want to find the nearest tenth of a degree. So that means that we want 1 decimal. So if we go ahead and put that into the calculator, our angle is going to be 29.0 degrees. All right, let's take a look at this problem. It says you are standing on level ground 800 feet from Mount Rushmore, looking at the sculpture of Abraham Lincoln's face. The angle of elevation to the bottom of the sculpture is 32 degrees, and the angle of elevation to the top is 35 degrees. We want to find the height of the sculpture of Lincoln's face to the nearest tenth of a foot. All right, so this one is going to involve a little bit more than just your basic triangle here, but we do want to start off with the triangle. So if it says you're standing level ground 800 feet from Mount Rushmore, we're going to have that vertical side be representing the height of Mount Rushmore, and so we want 800 to be on the bottom. It says the angle of elevation to the top of the sculpture is 32 degrees. From the bottom of the sculpture is 32, and then from the top is 35. So essentially, they're giving us two angles that are technically going to represent the bottom down here, and it's based off of his face. So think about this. Like, say, where I have this line, this right here is Lincoln's face. Okay, so that means that, hold on, now I have to, it's not cooperating here. We are technically going to have multiple triangles in this picture, and technically that's supposed to connect nicely from the vertex here. That's better. Okay, so it means that this little angle down below, that is going to the bottom of Lincoln's face. So that's the 32-degree angle. And then the whole entire triangle angle, this big angle down here, that entire angle is going to the top of Lincoln's face. So that's the 35-degree angle. Okay, so essentially then we want to find the height of the sculpture of Lincoln's face. So we want to figure out x, but that little x is not actually inside of the right triangle. So we can actually separate this. We have two different triangles. We have 800, and let's call that 32-degree angle. We want to find, let's call that side A. So that's the height down to the bottom of Lincoln's face. And then we have the second triangle, still a distance of 800, but with that 35, it's the entire height that goes to the top of Lincoln's head. So if we can figure out A and B, because notice that this whole entire thing is B and this is A, hopefully in order to find X, you can visualize this. I want the entire height of Mount Rushmore up to the top of Lincoln's face down, and then I want to subtract the entire height to the bottom of Lincoln's face, and that'll just give me Lincoln's face. Okay, so we're going to have to do trig twice. So I'm going to do both of these triangles. Notice that we're going to use tangent for both of these. So the tangent of 32 is going to equal A over 800. So I'm going to multiply both sides by 800. That gives me A. All right. It says that we want to round to the nearest tenth of a foot, but I don't really want to round until the very end. So 800 times the tangent of 32. I would say we want to go more than a few decimals. So let's say that A is 499 point. Let's do 4 decimals just to be on the safe side. So 895, and then technically it's 48. So I'm going to say 55. Okay, so I don't want to completely round until the very end. But then we're going to do the same setup for the side for B. So we're going to have the tangent of 35 degrees to equal then B over 800. We'll have to multiply both sides by 800 to get rid of that on the right. 800 times the tangent of 35 is going to be then, if I round to 4 decimals, we'll have 560.1660. So now I just have to subtract those. So to find what I'm looking for, I'm taking that and subtracting this. And then from there, we'll want to round to 1 decimal. Okay, so notice that we end up with, in the calculator, 60 points, and then we have 2705, and so nearest tenth means 1 decimal. The 7 rounds that 2 up, and our units are feet. So Lincoln's face is going to be a height of 60.3 feet. All right, so now let's start talking about bearings. In navigation and in surveying, the term bearing is used to specify the location of one point relative to another. So in each of these pictures, the bearing is going from O to P. We always want it to be an acute angle, and we always want it to be measured on that north-south line. So essentially on like the y-axis, okay? Think about a compass, north and south, you're going up and down. So notice that the picture, we have 40 degrees, it's being formed with that north-south line, and that's why we want to keep it 40 degrees. So if you look at the compass, we are going north and it's going to the right, so it's also going east. So north, 40 degrees east. In the middle picture, notice that we have the 65 degrees being formed with the north, and it's heading to the left, so it's going west. So it's north 65 degrees west as the bearing. And then in the bottom, or in the third one, we're on the bottom, so it means it's going south. We're going to the right. It is an angle that's formed with that y-axis, so we want to keep that 70. Okay, if we were given a number, like in this first picture, if we were given 60, we would have to subtract that from 90. I guess that wouldn't get you 40, it would get you 30, but then we would have to use the 30. So not every single time is the number that I give you the number that actually goes in the bearing. So you just have to be careful. It's the acute angle that's always formed with that north-south line. Okay, so here's a diagram. We are going to figure out the bearing from O to B first. So notice that O to B, we're looking at this particular ray, and I always want the angle that is formed with that north-south line. And so luckily for us, we already have that. Notice with it being in that second quadrant, we are north. We can keep that 40 degrees because it's formed with that north-south line. And we are on the left side, so we are west. So north, 40 degrees west is the bearing from O to B. In the second problem, I want the bearing from O to A. So we're looking at this ray right here. Notice that the number that they're giving us is 20, but that is being formed with the east-west line. I need to figure out the angle formed with the north-south line. So, like I mentioned previously, because it's in a quadrant, each quadrant's broken up into 90-degree angles. I just have to subtract 20 from 90, so we are really dealing with a 70-degree angle there. So notice that the ray is in the first quadrant, so that means we are going north, but it's really 70 degrees Because we're moving to the right, we are talking about going east. So north 70 degrees east is our bearing. If I look at the bearing from O to C, that's this ray here in the third quadrant. So remember, in this, I need to have the angle that's formed with the north-south line, and that would be this angle that is not listed. So we have to use that 75 degrees. We have to subtract it from 90, and that gives us then a 15-degree angle. That's what we want in our bearing. Because we're in the third quadrant, we are going south. We have that 15-degree angle. Because we're in the third, we're going west. So south 15 degrees west would be that answer. And then finally, the bearing from O to D. So we're looking at the ray here in the fourth quadrant. Notice that the angle that's given is formed by that north-south line. So that 25 degrees is the measure that I want to use. In the fourth quadrant, because we are going down, it's south, we'll keep that 25-degree angle. We're going to the right, so we are going east. So south 25 degrees east is my bearing. So go ahead, pause the video, and see if you can find the bearings of these two problems. So remember, we could not use either one of those measures because they were not formed with the north-south line. So I had to subtract 87 from 90 to get my second answer. That's why it's 3 degrees. I had to subtract 22 from 90 to get my first answer, so a 68-degree angle. And that's us solving a right triangle and doing some bearing problems.